Dirty gardening. Okay. The problem with U.S. agriculture is that it's serious, the way that we do it is seriously depleting the minerals. And one of the reasons is that the tendency is to, at the end of the season, everything that was growing, all the debris that's left after the crop, all of that is taken off the land. So we're losing it. Yep. We're going to talk about the story of a leaf. A leaf absorbs minerals from its root system. The leaf dies. Some root hairs die as the plant dies. Minerals are left on the surface of its leaf. They're just at the edge of the surface, underneath, if it's roots. That's the natural cycle of renewal. Things die, things decay, it goes back into the soil. So we clean up the mess, and my question is cleaning the garden a good thing? Where do the minerals go? Probably into those green bags that get collected by the city on a regular basis. So how can we let nature help us? I have 3 examples here of some tools that can be used. The chisel plow, if you look at it, God, I wish I had the laser. There's about 7 different slices. Each one of those half circles cuts a slice through the soil. So what you end up with is you're not turning the soil over, you're opening it. You're slicing it. Digging forks work this way. You push it down, you rock forward, you rock back, you open the soil, lift it, and move on to the next one. So rock forward, rock back, and then move on to the next one. So what you're really doing is opening up the soil, and it's just different ways of opening it. So you don't want to turn over the soil. This is nature helping. Tilling revs up microbes with an oxygen feast on the nutrients, and then they die. Don't till. Plus, we learned in soil that it breaks up the aggregates, which you don't want to do. You want the aggregates remaining. That's the structure of the soil. You compost in place. Leave the litter. Litter builds soil fertility, returns the minerals and the nutrients. You want to leave weeds. Of course, the secret to leaving weeds is not to let them get to the point where they've got seeds on them. But you can chop and drop is the permaculture's term for that. Is you chop them in place and then let them drop, and they stay, they overwinter there. It doesn't create a great look. But leave dead plant material or reuse it in a compost pile. Use insects, animals, and mulch to help you. The insects and animals can help with weeding, insect control and fertilizer. The animals can help with weeding, insect control and fertilizers. The mulch also helps with that. Attract with ground covers. This is how you attract those insects and animals that are going to help you. Is attract with ground cover, stone piles, log pits, an island for frogs and lizards. Lizards like rock piles. Thoughts on dirty gardening? You do have to remove the diseased debris. You really don't want to leave that around. That's not going to get you anything. So I know that you hear that you're supposed to clean up the garden because the pests are in there. But not only are the pests in there, so the beneficial insects overwinter in that same environment. So if you remove the debris, yes, you're helping remove the pests, but you're also removing your beneficials. Keep as much healthy debris in place, or as I say, for as long as you can stand it. Because I know it just gets on some people more than others. What are the permaculture design principles? How to use the elements. That's what we're going to talk about. This is the 10 that I've seen 12, I've seen 8. You know, it's kind of what the author wants to use. But if you go back to Mollison's book, I think he has it through number 8, I think. But we're going to go through each one of these one at a time. So I won't read them to you. Relative location, that is, it's not where you place something, it's where you place it with the elements it has to work with. And the idea is to place them so that in your design, so that they can assist or connect with each other. So you want to minimize transport and use natural forces where you can, like gravity. And remember that the outputs of one element are often the inputs of another, especially because we're in a process. So the output of one process is the input to the next process. I love this diagram because the guy has had his rocks for his patio or whatever. He's had them delivered at the base. So now he's got to get them up to the top. He's made work for himself. If he had it delivered up at the house, he wouldn't have to do that. If he had delivered him at the house, but he wanted to use him where he's standing, he could have at least rolled him downhill. But as it is, he's made work for himself. So some examples of relative location, you could place a water storage uphill and use gravity to feed it. You do some of that maybe with a rain barrel. You know, it has to be higher than the soil around it, and it has to be, the water has to flow to wherever you want to use it. So you need to raise it in order to get the pressure. Vines on the south side of the house will provide shade. So it's the relative location. It's not that you have a vine, it's that it's on the south side helping you out. You place a kitchen garden near the kitchen. Then you don't have to walk so far. It makes it easier to cook with it. So this is the ideal placement of elements if you can do it. And you have to have a slope, obviously, to make this work. But the cold night air is coming through the trees and warming. It shows you where the night condensation is and where the, this is what I'm trying, the winter freeze line, frost line. Between that is the best horticulture. You place your house in just below the key point. You place the water above the house and then gravity can help you feed it. The crops that you're going to use a lot are growing around the house. Then you have an orchard below, but it's still pretty much above the freeze line. Livestock below that, and then water storage at the base. So that's your ideal, and it's convex up here, concave below.
And the soil on the bottom is softer, not as rocky, because it has decomposed over the years and broken down. I have that hill, I know.
Perfect. And the better quality soil is at the bottom too, because of erosion. So number 2 is multiple functions. Each element performs more than one function. And the example here is a pond, which gives you fish culture, or can, irrigation, fire control, and it can bring in wildlife. Wow, it's fast. Function backup. Each important function, that's water, food, energy, fire protection, those are all backed up in some way. They're supported by many elements. An example of this is the house that has the solar panels for heating. Can have a backup wood stove. Picture the wood stove with a water jacket around it, and you can get hot water. So the wood stove can provide, with the water jacket, heat and hot water. Energy planning. Did I lose one? No. Okay. Energy planning. So you want to reduce the use of energy through planning and design. Kind of back to the oil, but also your energy. We're going to have, on the next slide, you're going to see zones 0 through 5, where 0 is the house. The high-use elements are nearest the house. The low-use elements are farthest away. And you have a lab. You always have to have a lab. That's where you're going to go and see how Mother Nature does it. And that can be on the outer edge, or in some cases, it's a wildlife corridor that cuts all the zones. We're also going to talk about sectors, which are pie wedges in this case. And they're going to show you where the sun, the wind, the cold, that sort of thing are. Then we're going to put the two together. But this is the starting point for doing the design and landscape, is getting familiar with where the zones are and where the sectors are. An example is putting your vegetable garden near the house, so you can pay attention and you can see a visible reminder that something has to be harvested. Here's the zones, 0 through 5. In this case, 5 is the wild, where nature, where your lab is. And it talks about here, the personal elements are number 2, that's where bees are. Then orchards and livestock and commercial crops and managed rangelands, and then wilderness. Here's our sectors, and now you're seeing where the sun is in the sky seasonally. So you're seeing in the summer, which is the one on the right, that's the highest. Winter is the lowest. Spring and fall are in between. We're going to have even more when we start combining them here. There it is. So the combination of zones and sectors. Now you've got a really interesting map of your property. And you can see the aqua is where the winter sun is. The yellow is where the summer sun is. You can see where the hot summer wind comes from in that sector. A fire-prone area. You can note the wildlife corridor. Now the nature is in the corridor. You can see where a cold winter wind is. You can see a bog area or a wet area that you've got. And you still have your zones out from the house. And now you can see where north is. The use of bioresources. They're going to help us, plants and animals, provide fuel, fertilizer, tillage, insect control, and weed control. And the idea here is that you build that up on site, so you don't have to bring it in. No external inputs, or reducing your external inputs.
Is he moving it? Is it movable so that the animals can fertilize as they go?
We're going to talk about it in just a second.
Oh,
Thank you. That was a good lead up. So you can save energy and do work at the same time. The key to using animals in particular is what choice, which animal do you use for which purpose? And also the timing. When do you bring them on? How long do you leave them on? When do you take them off? That's rotation. So we've got cover crops, green manure cover crops. So you're going to add nitrogen. Insectary plants, those are plants that attract beneficials. Mineral miners bring minerals from lower in the soil up closer to the surface. Some plants can do that, a lot of plants can't, but they can take advantage of it if you have them next to a mineral miner. Nesting boxes will bring the birds in and they can help you with bugs. Chicken tractor, this is a chicken tractor. A chicken tractor is a mobile coop. And it allows, there's a fence, a small fence, like an electric one, of the area that they want the chickens to debug, to stomp down. grass to add some fertilizer pellets to, and to do some tilling for them. So that's the tractor sits there for a while, and then when the chickens have done what they want them to do, then you move it on to another, you rotate it, you move it on to another location and let them work that area. Goats you can use for weed control. Every time I see goats and weed control, I think of Charlie Finley in the Kansas City 80s, who used to have above right field. He used to have grass in the stadium, and he hired goats to come and take care of his grass for him. So he didn't have to mow it, or have it mowed, or pay to have it mowed. Bees are another thing that you could use. On-site energy recycling. So we want to, honest to God, I'm not doing this. You want to keep energy on site by eliminating transportation, packaging, and marketing. So we're going to create our own. Catch it, store it, and use it before it dissipates. So examples of that would be kitchen waste to compost, manure to biogas or soil, gray water to the garden, and I'm looking forward to being able to use gray water, and green manure into the soil. These are all ways of recycling energy. I love these. This is Joseph Phelps. These are his assistant winemakers here, helping maintain the soil and maintain the grass, and that the grass keeps the soil in place. They've got lots of slopes. They've got bees, apiaries. It's using animals to help. And a mobile chicken coop. Pack and stack, Stephanie I know talked about this. It's packing plants densely and using height for shape. You can use it for shading, but you can also use it for climbing plants. Don't plant more than you can care for. That is in care for the earth. Don't use more than you can care for. Increase the yields on what you have before you spread out and creep and start opening up more to cultivation. And do more with less. So how are we going to do it? We're going to pack plants densely. We're going to stack them, and that can be the corn, bean, squash is one example, but hanging baskets is another. Time stacking, you can overlap crops so that as one crop is being harvested, the next crop is beginning to grow. How does natural plant succession work? Well, this is sort of an extension of what we did earlier, but you start with exposed rocks, and your grasses and weeds come in, and then you've got perennials, herbaceous plants and shrubs, a young forest, a mature forest, and finally the climax forest. And our question is, can we accelerate that process to build good soil faster? So how do we do that? We reduce what we want to do is reduce the natural time for succession through which plants we choose, because some plants are better than others at helping to build soil. When do we use them, and in what sequence do we put them? Some examples that we could do is with plants. Green manure, mulch, compost. We can use animal manures, and we can substitute species and use the ones that are best. Wow. Okay. Diversity, that was another thing that Stephanie talked about. The sum of diverse yields is better or higher than a mono yield. We're going to talk about plant yields, which are putting together a series of plants that benefit each other and that would be grown in proximity. The one that we all know is corn, beans, and squash. It turns out there were actually 4 components to that. It was corn, beans, squash, and the pollinator plant, bee plant. You can put deep roots next to shallow roots, so you can plant carrots with lettuce, as an example. That reduces the root competition. If you think about prairie plants and the flowers on the prairie, they're often deep-rooted plants that grow next to or beside the grass, which has not so deep roots. But for the plants to be successful, the perennials, the wildflowers, whatever, in a prairie, they have to have deep roots. You can disperse yields over time. So indeterminate tomatoes versus determinate. If you grow determinate, then they all pretty much come through at the same time, and you can harvest them then. And that's what they were developed for, is so they could be industrially harvested. They all come to it at one time. You don't have to keep sending the machines out or the people out to go pick up tomatoes. So indeterminates provide you tomatoes all season. Ever-bearing strawberries, same idea. Dispersing the yield over time. Tubers that you can dig on demand. There's another idea. And fruit trees. You can have early season fruit trees, mid-season fruit trees, and late season fruit trees. So you have some kind of fruit, whether it be apple or peach or whatever, throughout the season. Polycultures, yes, we believe in polycultures. We do not believe in monocultures. No diversity there. A mixture of perennials and time, over time. Edge effects. We talked about the undulating edge and the wavy edge earlier, but the concept here is reduce pathways, increase edge, and reduce effort. Increase edge is just a mantra of, along with create no unnecessary work, it's increase your edge. Interestingly enough, and it makes sense, the boundaries between life zones are the most productive. There's a richer group in there. But if you think about it, if we have grasslands and piña, okay, here's the grasslands, here's the piña. In the grasslands, I have grassland species. In the piña juniper, I have low forest species. But where the two zones touch, I have grasslands and I have piña juniper. So I end up with a richer set of life forms. Another edge effect, the herb spiral. As I said, if you spread it out, it takes a lot more footprint. And at the same time, you get, with the elevation, you get more space, a little extra space. And you get microclimates. So the boundaries of the richest area, geometry of edges, you hear edges talked about a lot in permaculture. Zigzag is kind of like the undulating edge. Lobular or keyhole, that's the mandala we looked at. That's an example. Elevation, get elevated. Waffle, if you sink it, you get a little more edge. And curving gives you more edge than a straight line. I use the example forest edges in housing developments because that's a negative edge effect. When houses move into the forest, particularly as a development, the animals start moving into the forest and away from the edge. There's more light on the edge, so the trees, the species of trees are different, and you don't see the same, you don't see as rich a form, and this is the negative effect of edge. And again, just having the animals move inland doesn't help. Practical permaculture, working with the elements. So we're going to talk about natural infrastructure, which is soil, water, and energy. Plants, animals, and it's a broad definition of animals. It includes insects, pollinators, and humans. And then buildings and roads, the infrastructure, could be houses, could be barns. But we're gonna consider all of these in our design. Starting with natural infrastructure, the soil is the base of the pyramid of life. Our goals: manage the nutrients, manage the soil bioactivity, and it's a two-step process. So we're going to prevent loss and we're going to improve it. What do we do to prevent loss? We're going to cover exposed areas, we're going to control the overland flow of water, we're going to choose fast-growing plants. And how do we do that? We do it with no-till, so tools that don't turn over the soil. Encourage the worms or deep-rooted plants. Daikon radish is the poster child for that. That help aerate and reduce the compaction in soils. We're going to add mulch and compost. We're going to add trees. We're going to place brush piles across slopes. All of these to help reduce or prevent the loss. Improving it, what do we do to improve it? Well, we're going to loosen compacted soils. We're going to, of course, test our soil, add organic matter if it's needed, correct any deficiencies that we find, and we can do that with manure, green manure, or minerals. Encourage bioactivities, so introduce redworms, reduce tillage. How are we going to do it? By managing the plants and animals that we choose. Mechanically, by using those tools, the digging forks and the chisel plow, for example. Or we can create a soil, we can create ours, which you do with raised or lowered beds, where you buy your soil and bring it in. Or if you're composting, you can use it. This is just an example of sheet composting. And it talks about 5 layers in a 4-meter square area, and you water in each one, and you get fertile soil. What I found interesting in this, and this diagrams the steps, the wheat barrier. Jim Brooks, who used to own, I don't think he does now, but he used to own Soilutions, and he has redworms available. And he said, or he told me, that the redworms really like cardboard. So when you're looking for your weed barrier material, if you want to attract the red wigglers, then cardboard is the thing. He said it's not that they like cardboard, they like the glue. I don't know, but he's had more practice than I have. This chart I love, and I know Dr. Idowu had this, but it's, if you think of each of these trophic levels as a column, each of those has a function. The first one is plants, so it's photosynthesis. But at the first level, you have the waste residue and metabolites from plants and animals and microbes, and the plant, roots and shoots is what you're talking about. But as they die, they form food for the next level up, which is decomposers and pathogens and parasites and root feeders. This chart, which is described as life and death in the soil, creates fertility. I've always thought of it as Kui 2, because it's, you move up the level, and everybody eats something, and generally it's one level back. But it shows you all the different types, or some of the different types of insects and animals and predators and birds, and everybody contributes. Soil, the importance of mulch. And I wanted to explain at the beginning, because a lot of people, at least new to gardening, don't understand the difference between mulch and amendment. Mulch goes on top. Amendments go in the soil.